What makes the sun and the earth attract each other, but not this biscuit or this coin? Or do they? Let's find it out. By the way, I'm Meer Thahir of class 9 of Vidyashram Kolapakam by Porur. So, according to Sir Isaac Newton, every particle attracts every other particle in the universe with a force. This force is called the gravitational force. So now, we are going to learn about what the gravitational force depends upon and about this peculiar tiny value called the gravitational constant. On what Newton stated in his universal law of gravitation is that a particle attracts every other particle in the universe with a force that is directly proportional to the masses of the objects and inversely proportional to the distance between them. Yeah, this is what is stated. But now let's make it clear. Take two objects, a cricket ball and a football. We know that force depends upon the masses. So we can write force of gravitation is dependent upon the mass of the cricket ball multiplied by the mass of the football. Now, the another thing is the force depends upon the distance. To make it clear, let's take the example of Earth and Neptune. We know that Earth and Neptune are 3 billion miles away from each other. So the force of gravitation from the Sun to the Earth is pretty high and to the Neptune is pretty low. That's why it's lying in the outer shell of our solar system. So now we know that force of gravitation depends upon the distance between the objects. But this distance matters so much that it has a square over it. So force of gravitation depends, that is inversely proportional to the distance squared. By combining these two, we get force of gravitation is directly proportional to the masses divided by the distance squared. But this equation is kind of incomplete without an equal to. So let's just put an equal to over there and add a constant. So force is equal to mass divided by distance square multiplied by a constant. But this constant, we can give it a name. It's the gravitational constant. Now, what's this gravitational constant? Most of you might know it. It's 6.674008 in 10 power minus 11 meter cube per kg per second square. But how? Let's find it out. Take the Earth and this donkey. Maybe not a pokeball which weighs 100 kilograms. So we know Earth's mass, which is nothing but 5.972 to 10 power 24 kilograms or 6 into 10 power 24 kilograms. Now let's assume that the pokeball is at the ground, which means the distance between the two objects is the radius of the Earth, which is 6,371 kilometers. So we know the radius of the Earth and mass of the Earth and mass of the object. So how could we find out the value of gravitational constant? It's simple. Substitute the values in the gravitational constant formula. We'll just change the formula a little bit. We'll just put gravitational constant in the left side and send the force of gravity to the RHS. So gravitational constant will be equal to force of gravity multiplied by distance square divided by mass of object 1 and mass of object 2. And now we can do something here, right? The force of gravitation, which is nothing but a force, can be written as mass into acceleration. What is the mass? Mass of the pokeball. And what is the acceleration? How do you find it? It's simple. Just push a person from a lighthouse and calculate the time it takes for the splash to be heard to your ears and the height of the lighthouse. So you can use the formula S is equal to ut plus half at square, where u is 0 because initial velocity of a standing object will be 0 meter per second. So we can now find out a, which is 9.8, which you guys know, 9.8 meter per second square, and mass is the mass of the pokeball. Now let's just keep those aside and find the value of gravitational constant. So we know the gravitational constant formula, which is force, that is mass into acceleration, multiplied by distance square divided by mass 1 into mass 2. The masses get cancelled because both are the masses of the pokeball. Remember? And the distance, we know it. It's 6371 kilometers. And acceleration, 9.8 meter per second. And what's the mass of the Earth? It's 5.972 or just 6 into 10 power 24 for easy calculations. And so we got the value. And let's just use our calculator. Boing. It's nothing but 6.673 in 10 power minus 11 meter cube kg per second square. The meter cube kg per second square comes from the formula. Hope you guys understood. Thank you for watching and see you guys later.